So let's try a few of these problems that have a combination of some of the simple rules that we were looking at earlier. For example, in this problem, you'll notice that there's two things going on. We have exponents that are raised to another power, and then eventually we were going to want to multiply things that have common bases, because we have a's here and we have b's here as well. So for this, for a lot of these problems, there'll be several ways to go about them. So sometimes I'll mention maybe a different way that might be easier, or just a different way that maybe helps you think about it a little better. For some of these, you'll just learn, the more of them you do, you'll find ways that you prefer to work the problem. So you'll see a little bit what I mean as we go through some of these. So a problem like this, I have to remember that I can't really multiply these a's together because they're kind of trapped with these exponents on the outside. So I'm actually going to take care of dealing with the exponents first. So I want to get rid of this 3, so I'll think about distributing this 3 out to the exponents here, and I'll distribute out the 2 to these exponents here. And I'll end up getting a to the 9th, b to the 6th, because remember we're multiplying these exponents since we're taking them to a power. And here I'll get times a to the 8th, and then b squared. Now I'm going to multiply two terms that have common bases. So both of these have a's, and then both of these are b's. So now this is when I'm going to add the exponents. So make sure you remember the difference in when you should multiply exponents and when you should add the exponents. So in this case, I'll get a to the 9 plus 8 times b to the 6 plus 2. So a to the 17th times b to the 8th. And that's as simple as we can get this answer. Now, I can also do this with some negative numbers. Again, it's not going to change the process, but I have to be careful because anytime we deal with multiplying negatives, you have to make sure that you don't put, for example, a negative where there should be a positive, or a positive where there should be a negative. So something like this, a to the 4th, b to the negative 2, all to the negative 1, times a to the negative 1, b squared, all of that to the, let's make this to the negative 3rd power. Again, I know I'm going to end up multiplying some a's and b's together, but I have to take care of these exponents on the outside first. You can kind of think of them as they're trapped in by these exponents. You need to take care of them first before you can go anywhere else. So again, I'll think about distributing this negative 1. Again, the reason I can distribute that negative 1 and the negative 3 is because these are separated by multiplication. If they've been separated by addition or subtraction, I can't do it. But as long as they're separated by multiplication and division, then I'm good to go. So 4 times negative 1 is negative 4. Negative 1 times negative 2 is positive 2. Negative 1 times a negative 3 will be a positive 3, and then 2 times negative 3 will be a negative 6. So now I'm at the point where I can combine these like terms by multiplying a to the negative 4th times a cubed. So this will be a to the negative 1st, since negative 4 plus 3 is negative 1, and then 2 plus negative 6 is b to the negative 4th. If I wanted to write this without the negative exponents, I could write this as 1 over a to the 1st, b to the 4th. So if you see that in a book, textbook or instructions on a test, for example, to write it without negative exponents, this would be the last step that you want to make sure you take. Let's take the same idea and do this with some division. So something like this, 2x to the 4th y divided by 4x y, all that to the negative 3. Now in this case, there's a couple of ways to do this problem. I could go ahead and distribute out my negative 3 to 6 terms, right? 1, 2, 3, 4, 5, 6, and then divide everything. This will work just fine. However, there's a little quicker way to do this that you will get the exact same answer. So maybe I'll do it both ways just so we can see. The way I like to do these problems is to take care of the inside first and get it as simplified as possible. And remember, I can do that because this entire thing is to the power. It's not like these are separated. This to a particular power and this to a particular power. It's this entire fraction all to a power. So I can actually take care of simplifying things in this fraction first and then apply the negative 3, and it'll make my life a lot easier. So I can go ahead and say, well, 2 will go into 4 twice, so this 2 will go in here twice, and so I enter the 2 in the denominator. X to the fourth, actually, this might be a little easier to do like this. We'll say 2 divided by 4 is 1/2. We'll just put this as a 1/2 out in front. You'll see why in a second. Then I can say x to the fourth divided by x to the first. That'll be x to the 4 minus 1, so that'll be x cubed. Then y to the first divided by y to the first is just going to be 1. So these will actually cancel out. So I'm just left with 1/2 x cubed. All of that raised to the negative third power. Now I can distribute out my negative 3 here, and I only have to distribute it out 2 times now instead of 6. So you can see why this maybe is a little more efficient. So this will be 1/3 to the negative third times x times 3 to the negative third. This negative third power, I can make it positive by flipping the fraction. And this, of course, is x to the negative 9. This is 2 divided by 1, which is just 2, and then 2 cubed is 8. So my final answer will be 8 times x to the negative 9, or 8 over x to the positive 9. Now, I mentioned that I could have done this a different way and get the exact same answer. So let's see if I can do that. Let's take the same problem and do it the slightly longer way. Again, you wouldn't be mistaken for doing it like this, but it might take you a little more time. So let's see the difference here. So let's say that, I'll just put this over here so we remember what it was to make sure we can check our answer. So 8 divided by x to the 9. So let's say I want to distribute out the negative 3 first. Well, I have to distribute it 6 times. So to all 6 of these terms. So I end up getting 2 to the negative 3 times x to the negative 12 times y to the negative 3, multiplying exponents. All that over 4 to the negative 3, x to the negative 3, y to the negative 3. And now I can try to start combining things together. Well, let's see. This is not too bad. Y to the negative 3 divided by y to the negative 3, they cancel out. X to the negative 12 divided by x to the negative 3, this will be x to the negative 12 minus the negative 3, so plus a positive 3. Over here, 2 to the negative third, that's really 1 over 2 to the positive 3, so this is 1 over 8. And then 4 to the negative third, this will be 1 over 4 cubed, so 1 over 64. So I can really think of this as 1/8 divided by 1 over 64. You can already see where this is a little more complicated doing it this way than the other way. At least we have a few extra steps that we have to deal with. So let's try to finish this out. 1/8 divided by 1/64, that's the same thing as 1/8 times 64 over 1. So that'll be 64 over 8 times x to the negative 9th, or 8 times x to the negative 9th, which is actually the exact same thing that we got before. So 8 over x to the 9th. So again, there's nothing wrong with doing it this way, but it is slightly more complicated than the first way we did it. The more of these you'll do, you'll start to recognize, oh, this will probably be better if I go this way, or this will probably be better if I start the problem this way. It's just kind of an experience thing. So let's try another one. So how about this one? X squared over y to the negative 3, all to the negative 2nd power, times x to the negative 2 times y to the negative 5 over z cubed. All of that to the 3rd power. Now you notice in this case I actually can't combine any of the terms inside of the parentheses because none of them have the same basis. So I'm actually kind of stuck, and I have to do my distribution of the exponent before I do anything else because nothing in there will combine. So I have to go ahead and take care of this. So x squared to the negative 2, this becomes x to the negative 4. Y to the negative 3 to the negative 2, this becomes y to the positive 6. All of this times x to the negative 2 to the positive 3. That'll be x to the negative 6, negative 2 times 3. And then y to the negative 15, and then z to the 9. Again, I can do this because everything here is separated by multiplication or division. There's no addition or subtraction in here. So now I can combine terms, and actually I'm going to think of this, I can think of this a few ways. I could either think of this as x to the negative 6 over 1, or I can think of this x to the negative 6 as 1 over x to the positive 6. And now I can just multiply all three of these fractions together straight across. So I'll get x to the negative 4th times 1 times y to the negative 15th all over y to the 6th times x to the 6th times z to the 9th. And now I can just do my combinations. So x to the negative 4th divided by x to the 6th. This will be x to the negative 4th minus 6, so x to the negative 10. Y to the negative 15th divided by y to the 6th. This will be y to the negative 15th minus 6. So y to the negative 21st. And then the z to the 9th doesn't have anything to combine with, so he just hangs out. I would probably write this where everything is positive, so I would probably write this as 1 over x to the positive 10, y to the positive 21st, z to the 9th. It looks a little nicer to me like that. But there's nothing wrong with this answer as well. They're both totally legitimate. But this is as far as we can go, of course, for this particular problem. Okay, let's do one more that seems like it's a little more complicated, but it's not really. So x to the 2m times y to the 4n plus 1 all over x to the 3m times y to the n minus 5. Now you might be looking at this and saying, oh man, what do I do when I have variables inside of my exponents? The main thing to remember for these problems is the rules don't change just because we change what's happening in the exponents. The rule stays the same. The rule says if you have a base to a power and then the exact same base to another power and you're dividing them, then you should just take the base to the top power minus the bottom power. So we don't care what it is, we're just going to take the top minus the bottom. Same thing with the y's. It's the base to the top power minus the bottom power. Now do be careful here, you need to put this in parentheses because you're subtracting that entire term, n minus 5. So I'll have minus and n minus 5. So actually I'm getting x to the 2m minus 3m is negative 1m. And then y to the 4n, I could really think of this as minus n plus 5 if I distribute the negative sign. So this will be 4n minus n, which is 3n. And then 1 plus 5 is going to be 6. So this is a perfectly legitimate answer here. Or if I want to write this without the negative exponent, I'll do x to the positive n, but in the denominator of the fraction. Alright, so what happens when we actually do have something that's separated by addition or multiplication? I'm sorry, addition or subtraction. I mentioned that you can't just combine things. If there's addition and subtraction, you have to be really careful. For example, in this particular problem, I can't take any of my variables and move them around the problem because they're all separated by addition or subtraction. So I can't move this a to the negative 1 up to the numerator, for example, and I can't move this b to the negative 1 down to the denominator. So this one might be kind of tricky, but the thing you want to do here is try to actually combine these two within the numerator and within the denominator first, and then see if you can deal with them from there. So what do I mean by this? Well, I'm just going to rewrite all of these. Instead of a to the negative 1 and b to the negative 1, I'm going to rewrite this as 1 over a and then 1 over b. And then the same thing for the bottom. So I end up having 1 over a plus 1 over b divided by 1 over a minus 1 over b. And what I'm going to do is actually just go through and combine these two into two fractions. Because I have a fraction divided by a fraction, I definitely know how to deal with that. So if I can combine these two into one fraction and these two into one fraction, I'm probably on a good path there. So I can combine this into one fraction. I need common denominators, so I can multiply this fraction by b over b and this fraction by a over a, and I'll end up getting b over ba plus a over ba. So then I have common denominators, so the next step I can put them together. I'm going to do the same thing here. I'm going to make the common denominator a times b. So I multiply this one by b over b and this one by a over a. So this will become b over ba minus a over ba. And now when I go to combine these, I'll end up getting b plus a over ba in my numerator, and then b minus a over b times a in my denominator. And you might be saying, well, what do I do with this now? Well, again, just think of your rules. If you have a fraction divided by a fraction, what do? Well, you take the top fraction and multiply it by the reciprocal of the bottom fraction. So we just take this fraction, flip it, and multiply it here. In this case, the BA will divide by BA, they'll cancel out, and then I just end up with B plus A over B minus A. And that's as simple as I can go. I can't combine anything else in here. I can't divide through these B's, for example, because they're separated by addition and subtraction. If it were multiplication, I could do some more work. But for example, I can't go through and just mark out this A and this A. It won't work out like that. That's a bad algebra.